Our poster is on the expiration rate of milk, and our problem was which milk out of skim, 1%, 2%, and whole milk expires first.
In the background, we discussed basically the pH of fresh milk and how the fat percentage of each type of milk that we used in the experiment, and basically that during this reaction it's a chemical reaction because you can't, after milk spoils, you can't go back.
Our hypothesis was that if the milk contains a higher percentage of fat, then it will expire quicker. The materials used in this experiment are a quart of skim milk, whole milk, 2% milk, and 1% milk, 4 clear containers, a fridge, pH strips, filter paper, labels, a permanent marker, and a measuring cup for 2 cups.
In the procedure, first we had to make sure that we regulated the refrigerator temperature and we kept it at 38. And then we labeled the containers, and then we poured 2 cups of one type of milk into a container and sealed it. And then you repeat it for the other type of milk, and then you take the pH level immediately and then once per day after, and then you repeat steps 4 and 5 until the end of the experiment, which is record results. And after the first milk expires, take the pH for the other 3 types for 1 day after.
In our data table, which you can see here, the results, basically we started at a pH level of 7, which was considered a normal pH level for all the milks, and they all had very similar expiration dates, as close as we could find them. And after about the 5th day was when we started seeing changes in the pH. And by about the 8th day, whole milk actually had expired first. It got to a pH level of 4.5, and we took the pH the next day of the skim 1% and 2%. Skim had the highest pH. It was still at a pH level of 7, and then 1% and 2% each were at a pH level of 6.5, so they were still pretty high up compared to the whole milk.
As you know, every experiment leaves room for error, and some of the limitations in this experiment were, well, the milk took a 20-minute ride home without refrigeration, which could have sped up the process of expiration. Also, there are different storage temperatures, could change the rate of expiration, because before it was stored in a different refrigerator, and then it was stored in a home refrigerator, so the temperatures could be drastically different, which could change the rate. And an improvement would have been regulating the time of the refrigerator doors were open, because if they're open for a long period of time, the milk could have been exposed to multiple temperatures, and that could change the expiration rate of milk.
In conclusion, we found that the hypothesis was correct. The milk that contained the high percentage of fat expired the quickest, with a fat percentage of 3.25%.